Kristen Stewart, 5/24/22. All right, give me a second to get ready here. This week I chose to present on the different feedback loops that are present in the female's menstruation cycle, specifically a cycle that does not lead to pregnancy. All right. So the menstruation cycle is measured by the ovarian cycle and the uterine cycle. This picture from Silverthorne, which is actually a great picture and has helped me a lot when studying to understand how these intertwine and align, goes over each phase and different hormonal levels, and then also the gonadal troponin levels. As we see on the bottom here, the uterine cycle is outlined. The three different phases are the menses, the proliferation, and then secretory phase. And the uterine cycle is much easier to identify for a female because it is indicated by bleeding. So that's much easier to see than the ovarian cycle. However, I am going to go in depth on the ovarian cycle. As we see, there's three different phases: the follicular phase, ovulation, and luteal phase. I will go in depth specifically what feedback loops are happening within these phases and which hormones are being regulated and secreted during each phase. Right. So first phase is the follicular phase, as mentioned. Estrogen is most dominant in this phase. This phase marks day one of the menstrual cycle. Again, it is noted by bleeding. And then also simultaneously, the gonadal troponin secretions are increased from the anterior pituitary within the brain. The direct effect from FSH specifically on the follicles is to bring them to be mature. As we see on the image on the right, the follicles start small, and by the end of the follicular phase, it is a lot larger. So FSH has a great impact on that maturing stage. When the follicles grow, FSH then acts on the granulosa, and LH acts on thecal cells, as noted in the picture of the left. Both of these functions of these cells is to produce hormones. And we see in this figure exactly which hormones they produce. The thecal cells directly affect the androgens, and the granulosa cells first is AMH. AMH is important because it decreases the follicle sensitivity to FSH. This is physiologically important because it stops multiple follicles from maturing or going through another cycle. So it pauses the follicles and says, nope, like we need to go through a cycle first before we can secrete another one. So that's the importance of AMH. And then you also have estrogen. As mentioned, it is a huge portion of the follicular phase. In this process currently, all hormones are under the control of negative feedback. We do see a glimpse of positive feedback from estrogen here, but mainly it is under the control of negative feedback. The book kind of incorporates the late follicular phase and ovulation together. I will talk about what is happening right before ovulation. That is a good indication of ovulation in the next slide. So ovulation is triggered by LH and FSH surges. We can see this in the right-hand picture, that there is actually a huge surge of almost well, both gonadotropins and then also uh, hormones. We see estrogen increases, and then we also see inhibin increase, and we start to see the rise of progesterone, and all of these are happening during ovulation. It is important to note that because of the high surge in all of these, estrogen creates a switch to create it to be a positive feedback loop, which leads to the GnRH surge, as we see in the left-hand picture. That surge creates a surge in LH, and the LH surge is important for ovulation. As we walk through, we can see that increase of GnRH, and then the LH acts again still on the thecal cells, and still only acting on the anagens, but now the anagens act on the granulosa cells, and the granulosa cells increase their roles. As we see, they start to secrete a small amount of progesterone, and again, high outputs of estrogen and inhibin as well. And lastly, we have the luteal phase. Progesterone is dominant in this phase. Estrogen is still present, but it doesn't have as big of an impact. We see that when pregnancy doesn't happen or implantation doesn't happen, the corpus luteum is what comes of the follicular cell. That is noted in the right-hand picture. The presence of the corpus luteum is also accompanied by high levels of progesterone, and that is noted also in the left-hand side here. Again, our book switched these up into two different phases, mid and then late luteal phase. This is because at the beginning of the luteal phase, it is still kind of coming down from ovulation, and we can still see that estrogen is somewhat high. There's going to be an increase in the progesterone, and inhibin is still rising. And then it finally switches over to a decrease in all of these. You see the actual simplified cycle here in the last part D here. And it goes back to normal. We don't see any more negative feedback loops. I did forget to mention that in this phase, it now switches back to negative feedback loop. So we went from a negative feedback loop in the follicular phase to a switch during ovulation to positive feedback, and then now we are back to the negative feedback of hormones in the luteal phase. Again, I just wanted to review this now with all the information given back to this original slide or image, just because it has great information. You can see the gonadotropin levels right here. We have FSH and LH, and the surges of them during ovulation. And then you also see the follicle development over the stage of the cycle. You see it slowly maturing in the follicular phase to releasing in ovulation, and if no pregnancy happens or implantation, then the corpus luteum is developed. You also see in the next one the different hormones that fluctuate through this cycle. All of these were noted in each different phase. And then lastly, what I didn't really hit on, but I think is important, is the uterine cycle and how the uterus and the lining specifically, the thickness, how it changes. We see the shedding in the menstruation, mensy part of this cycle, and then we see it slowly growing, waiting for implantation. But when it doesn't happen, so specifically in this case that I've been talking about, it doesn't happen, it will go back to shedding and start the cycle all over again. Here are my review questions from my presentation. I thought these were good questions that I also had to think through and figure out the answers. And so I will give you a second pause if you'd like to do those. And then lastly, I got all of my images from Silverthorne, so I added this. Thank you.